Our lightning visuals are working. We've got one strike appearing, but now I want to make sure that it damages our player before we start to add a bunch of other strikes. Let's make sure that it's fully functional. So inside of our start and counter method, we've got a loop that essentially spawns one piece of lightning or spawns a lightning strike. And then it waits until whatever time we've got here. And you saw that our timer kind of has to match our animation time for this to all work. If we take a look at our animation, I can go into Unity, go find our lightning object, and go expand it out. There's that base sub object. I need to make sure I unlock my inspector. Go take a look at my lightning strike, or even better yet, if I go to the base and go to the animation window, not animator, I can look at my lightning strike animation and I can see it actually play out. I can drag the timeline across and see that it actually is supposed to strike or do damage right here at 1.5 minutes. That's what the 1:30 is. 30 is half of a minute, so that's the halfway mark. So it's supposed to stop, go to 1:30, and then it's basically all the way gone before the 2-second mark. It looks like there's some keyframe out here at the end at 2:30. I don't know why it's quite so long, but it looks like it actually ends at just about less than 2 seconds. So I'm going to modify our code just a little bit to take advantage of that. And we've got a couple options when we do this, by the way. There's already an animation event that our animator has put into here. I'm actually going to delete that out because I don't want to have to tie in an animation event and have my designers have to come in here and modify and move the animation event when I know it's at 150. And if I want to change it later, I'd rather just have a slider in there for all of my B and counter settings that I can modify this setting on. Now, using an animation event can be good if you have lots of animations, you want to tie them all in, and your animators and designers are good at using it that way. But I find that for this situation, putting it into my B encounter is going to make more sense. So I'm going to open up my B encounter script, and we're going to add in a couple new fields. We've got a delay between lightning, which is right now kind of doing its job, but not really. I want to add an animation length and a delay to damage. So I'm going to just duplicate the line twice with Control D like I just did, and I'll put delay before damage, and then a let's call this lightning animation time. So the full time of the animation, that's going to be 2, and the delay before damage is going to be 1.5. I already know the values. I want to be able to modify them, but since I know them, it makes sense to put in an actual accurate value. Now inside of my loop here, inside of this while loop, instead of waiting for the delay between lightning, we'll wait for the delay before damage. And then we'll damage players in range. And we want to do players in range of our selected lightning object. So to get that, I'll just copy part of line 28 up to the end of the index and paste it in. That's going to give us a reference to the transform at that index in the list and pass in that transform. So I add the semicolon, home, and Alt-Enter to generate a method, which should give me a private method that takes in a transform because that's what we're passing in. I get rid of that private keyword. Then after we damage players in range, which we'll write the code for in a moment, we want to wait a little bit longer. We want to wait until the animation is done. So let's copy line 30 and paste it down here on line 32. And we don't want to wait for the entire animation time, right? If we go up here, if I just did it for this lightning animation time, then we would wait for 1.5 seconds, damage players, then wait for another 2.5 seconds. Now I could change this to be maybe a 0.5 so that it's the delay after damage, but I feel like having it just be the full lightning animation time is easier to understand. So I'm going to copy that and we'll just do a little bit of math. We'll paste in lightning animation time minus delay before damage. As long as these values are correct so that this number is always greater than this number, we should be pretty good. We shouldn't run into any problems. Now we can make sure that that's the case by adding an on validate. So we'll go up to the top and add one quick on validate and just say if the lightning animation time, so I'm going to copy that, is less than or equal to the delay before damage, then the lightning animation time is equal to the delay before damage. So that our lightning animation time will always get just kind of cranked up if we accidentally mess with this delay before damage. In fact, probably should adjust this. Let's do that. Let's change it so that our delay before damage has to always be less than our animation time. So here we'll just say that our delay before damage is equal to the lightning animation time. I'll just swap the order of those so that we keep the lightning animation time the same. I think that makes more sense. All right, so now we've got a loop here. We just need our final wait. So we're waiting for that amount of time. The last thing is to wait for our delay between lightning. So I'll copy delay between lightning, duplicate line 38, and paste it right in here. So we'll wait till the end of the shot and then play again when the next one is ready, or play again once our delay is done. Now, the last thing we need to do is damage our players. So here we've got our damage players in range method. And the easiest way, or I think one of the best ways to find all of the things in range of a specific place is to use the overlap circle method. So we're going to say var hits, or let's call this out again, int hits equals physics2d, PHYSICS 2d, dot, and then there's an overlap circle. Find this overlap circle method. You can see that this will actually return back a number, or the first object that overlaps. That's not what we want. There's an overlap circle all that will return back all of the objects that are within a circle radius of a specific position. That's close to what we want. But there's actually one method that a lot of people don't use, and I generally recommend you use instead of overlap circle all. If you're using any of the overlap alls, you should consider, or at least look at, using the overlap circle non-alloc, or the non-alloc versions of any of them. In fact, I would say you should almost always use them, especially if you're using it in something that's commonly called. And that's because it won't create a new array of things to save off the hits into. Instead, you will use a preset array or preset collection, and you'll just be filling those up. It saves you on garbage collection and essentially saves you from allocating memory and causing performance issues. So we're going to use overlap circle non-alloc, and we're going to give it the first parameter, which is the point, which is that transform right there. And I'm going to rename this transform to be lightning, because I want to make sure that it's not confused with my own local mono behavior transform. So I've got this lightning object. I'm going to paste in lightning.position as the first parameter. That was our position. Next, we need a radius. For that, I want a parameter or variable, and I'll call it lightning radius. This is that damage radius for it. And then we need a set of results, or an array of colliders. You can see right here, it's showing my collider 2D. So here, I'm just going to use underscore player hit results. This doesn't exist, just like our lightning radius doesn't exist. And then finally, I'm going to add in a layer mask so that we only look at players and we don't look at anything else. So I'll call this underscore player layer. I'll add in a semicolon at the end, and then I think I'll split these parameters out into new lines just so that it's easier to read. So you can see I've got my hits call, we pass in the position, we pass in the radius, the hit results, and the player layer. Let's create the radius first with Alt-Enter. We'll generate a field for it, hit F12, and change this to be a serialized field, and give it a default of about 1. 1 meter away is probably good, but we can always adjust this now. We'll go down, we'll add the player hit results. I'll hit Alt-Enter, generate a field for that, F12, and you can see we got a private array of collider 2Ds named player hit results. I'm going to remove the private keyword and add a little bit of spacing here so that it just looks a little bit cleaner. We got a little separation between our serialized fields and our regular private fields. The last thing I want to do is add our player layer. I'll hit Alt-Enter, generate a field for that, F12, and this one I do want to be a serialized field for now, so I'm actually going to cut it, move it up here, add a new line, copy the serialized field, paste it over the private, and then we're going to change this from an int to a layer mask, which actually inherits from int, so it's able to work just fine. So we can use our layer mask. Let's go click on it real quick. It does not inherit from int. I lied. But it has a value from int, and it will work in here. So let's go down and take a look at our code. We should have no more errors. Last thing we need to do is damage all of the players that we found. So we'll do a for loop, and we're going to loop through the number of hits that we got, because overlap circle non-alloc is returning back the number of things that it put into this player hit results. Once we loop through it, we'll just access the player hit result at that index, which is right now is actually going to be null. Let's take a look at this in a moment. It's going to give us an error, but we'll access that. We'll get its player component. So we'll say get component player. Let's capitalize that G. and then we'll tell it to take damage. And for now, we're just not going to give it a vector. I'm going to pass in vector 2 or 3.0 so that we don't pass in any damage vector so that it doesn't go flying off in any direction. Now, the last thing that we need to fix with this is actually going to be an error. But before we fix the error, I want to show you the error so you can see what it looks like, because you're going to run into this many, many times. I've seen it, I don't know how many times, and I think it's important to note. So we've got our B encounter, we've got our player layer. I'm going to switch it over to the player. I'm going to save our scene. We're going to press play, and let's watch the error appear. Go to the console and look at that. Argument null exception, value cannot be null. And it says the parameter name is results. So think for a second, don't click on it. Think about what this might be. If you can think about what the possible problem is, what could be null right now before you even click on it. Think through the code that we've written. Let's go take a quick look at it and think about it. And then come over here and click on it. Let's take another look. So here you'll see that it says the value cannot be null, and the parameter name is results, and it's in the overlap circle internal. And if I scroll down a little bit more, you can see the actual call stack. So it was called by line 42, and then which called line 50, which is in our damage players in range. If I click on it, you'll see that it's the overlap circle all, and it's this results parameter. The reason it said the results is if I hit comma here and go over, you see that the name right there is results. If I can get over there far enough, it's that name of the parameter right here. So the problem is that this player hit results is never initialized. So we need to initialize it to a new collider2D array and give it a default size. Usually we don't need a number probably as big as 100. I could probably go with like 10 since we're doing this on a player layer. But you can pick a size. Usually I go with 100 as a default so that we can have up to 100 things in that hit array. Again, it's players. I'm only going to have 1, 2, maybe 4 at most. So that's probably fine. Now, before I jump back into Unity, there's one other thing that I just forgot about, and you may have noticed as well, that I'm not turning the lightning back off after the animation's over. So I'm going to copy line 40 here and paste it right after 43. We'll change this to be a false so that we turn the lightning object back off after the time is run out. Let's go back into Unity, and we'll press play, and then I should expect to see my damage happening and some decent control here. Although we can only have one lightning at a time, I can control how often those lightnings appear and what their damage radius is as well. Let's see if I can take some damage. There we go. Look at that. Worked perfectly fine, and I expect it to work fine no matter what spot I'm on. Let's crank up the radius though, just so we can see that it actually does impact things like that. I took damage there, and if I want to turn down the delay between lightnings, I can put it at a 0, and we'll just constantly get lightnings firing off over and over and over with a huge radius. Let's turn that back down to 1 so that it doesn't insta-kill me. But now you can see that I've got some control, and it's very, very easy to modify. Let's stop playing now, go into plastic. Say we've added player damage and some lightning control.